Before we start Unit 2, I want to make sure you have the chance to go over some things that you did learn in previous courses that we are going to apply this unit. On 1 and 2 here, you're going to go through and list out your first 20 perfect squares or your perfect cubes, only 10 of those. So you're going to go through and do 1 squared, do 2 squared, and so on. I would try to do this without a calculator because it will be good practice since you do not get a calculator on any quizzes in Honors Algebra 2. I'm going to go ahead and keep talking through this. Feel free to pause the video so you have time to go through what you need to go through. On yours, you have a different set of problems, but I'm going to give you these as examples in case you need a reminder of how to do it. So these examples are not what's on your paper. Feel free to put these in your notes if you need them, or just listen to me talk through them if you remember them from before. When you are simplifying a radical, which is what we will start with in this chapter, but the better you are at it, the easier this will all be. The first thing that you want to do is to find the largest perfect square that divides into your radicand. If you haven't heard that word radicand before, your radicand is just whatever number is under your radical. So in number 3 here, the radicand is 112, 196, 252, and so on. So your first job is to find me the largest perfect square that divides into, say in this example, 112. So that's part of why I wanted you to have your list above, because you're going to look and see which of those. What's important, you might have multiple perfect squares that go in, but I always want the largest. For 112, the largest perfect square that goes in is going to be 16. 112 is actually 16 times 7. But you make sure you go through and you divide that in. So what you're doing in your calculator, if you need a reminder, you're doing 112 divided by 4, 112 divided by 9, divided by 16, until you find the largest one that will go in evenly. There are tricks to make this easier that you'll learn as you go. Just make sure you're thinking it through. So 16 was the largest one that went in. The second step right here is what I already did. I always rewrite the radicand as that multiplication. Okay, so I wrote it as 16 times 7 instead of leaving it as 112. What this allows you to do is to simplify your problem. Looking at this, the square root of 16 we know to be 4. I cannot square root the 7, so that's going to stay in the radical. And this would be my simplified answer for 112, for the square root of 112. Okay, I will work through a couple more just to give you some additional examples, and then you have plenty on your homework as well. If I look at number 5, again, I'm finding the biggest perfect square that goes into 288. 288 has a lot of perfect squares that goes into it. 4 goes into it, 9 goes into it, 16 goes into it, 36 goes into it, but the one that's the biggest is going to be 144. So when we write this, 288 is the square root of 144 times 2. So again, under the radical should always just be a factor pair where one of your numbers is a perfect square and the other is however you get to the 288. So 144 times 2 is 288. Oopsies. Then we're going to simplify. So the square root of 144 is 12. So this is really 12 root 2. In this problem, I gave you an additional thing to deal with. We have this negative 3 that was multiplied in front of the radical. So I'm going to drop it down and it's multiplied still as well. So I can now multiply this negative 3 by the 12 and get negative 36 root 2. Done. Okay. Next thing I want to do is one like number 7 or 8 to talk about how you deal with those variables. I'm going to do number 8. Looking at this 27, find me the biggest perfect square that goes in. What you should find, the only perfect square, in fact, that goes into 27 is going to be 9. So 27 is 9 times 3. Square root of 9 is 3. And you're going to end up multiplying that 3 by 5 because of the 5 in front of the problem, and you'll get 15. With these variables, though, we have to treat them a little bit differently. What I always do, I'm going to take these x's off to the side and I write them out, especially while you're getting used to it. You will reach a point where you don't have to. You're going to notice patterns again that will be important. And I think about pairs of x's that I can take out. And the reason for that, if you look at this problem right here, this 9 is really 3 times 3. The reason we were able to take it out of the radical is because it was a number times itself, so it came out as just that number. We can do the same thing with x's, but we just have to think about pairing them up into groups of 2 so that we have a number times itself. Okay, so really I have one pair of x's, and this one is going to come out of the radical as 1x. Anything that is left over, so say this one that I didn't circle, is going to stay inside the radical, and so my answer here is this 15x root 3x. Okay, what I'm going to do for you, just so you have extra examples, I'm going to give you the answers to 4, 6, and 7, so that if you want to try those, you can. Remember, you also have examples on your paper, so if you are confident in how to do this, feel free to just go through and try those on your paper. One note I will make to you, some of your calculators may simplify your radicals for you. You will not be allowed to use that calculator on your test if you notice that it's doing that. So just be prepared for that. It is a good check for you on your homework or anything that you may need, but we will not allow you to use it on a unit test if your calculator simplifies radicals. How you would know that, if you type in square root of 112 and your calculator tells you 4 root 7 instead of a decimal, your calculator will be banned on the test, quizzes, everything. Okay, for the rest, I'm just going to give you some directions. On 9 through 12, these are challenge problems that we do want you to try. They will be super important in this chapter. We cover it on day 2 of the unit. But I want you to think about, since we know how to simplify square roots, cube roots will follow the same pattern. So think about how you would do 9 through 12. And again, we will give you the answers. I'll write down the answers for these here as well. So that as you're thinking it through, you can check your work. We will give you the answers to your homework sheet as well. But this should be the answers to the ones on my notes paper right here. Again, these are different than the ones that are on yours. On the back of your sheet, you're talking about exponents. We have a section of this unit that is going over exponents. And during that section, we're going to add fractions into it. So it's going to be very, very important that you are confident in your exponent rules. So what I want you to do, whether you remember it or you need to Google it to look it up, go through and identify for me each exponent rule. So when I multiply like bases, what do I do to my exponents? When I divide like bases, what do I do to my exponents? Write it out and give me an example of each so that we know you know all of your exponent rules. Feel free to Google it if you don't remember, but make sure you have an exponent rule filled in for each. And then go through and try your problems. Again, yours are different than mine on here, but give them a try and make sure you remember how to do them. Your exponent rules will be extremely important later this chapter, so do make sure you take the time to review those.